Isthmus morphology influences debridement efficacy of activated irrigation, a laboratory study by Robberecht et al. In 2022. Irrigation is an essential aspect of chemomechanical root canal preparation. The irrigation solution serves to clean the parts of the canal system that have escaped the mechanical instrumentation. The root canal anatomy of the mesial root of mandibular molar teeth can be extremely challenging, in part due to the high prevalence of isthmus in these roots. Isthmus are narrow corridors or transverse anastomoses connecting two root canals. The conventional root canal irrigation methods is by means of a syringe and a needle. However, the penetration of the irrigants in the apical third and beyond the main canal is limited, resulting in suboptimal cleaning of the needle irrigation. Irrigation efficacy can be optimized using irrigation activation technique. These facilitate irrigation flow and distribution within the complex three-dimensional anatomy of the root canal system. The aim of this study was to investigate the influence of isthmus morphology on the debridement efficacy of laser-activated irrigation, eddy, and needle irrigation, and to explain the methods of isthmus cleaning by laser-activated irrigation and eddy activation. For the methodology, 4 root canal models were produced by CAD/CAM with different isthmus morphologies. 1. Long and wide. 2. Long and narrow. 3. Short and wide. 4. Short and narrow. A ribbon-shaped isthmus was designed connecting the two canals and providing a Vertucci type 6 configuration to the root canal system. The floor and the roof of the isthmus were positioned at 3 and 6 mm from the apical foramina, respectively. The isthmus were filled with a hydrogel containing dentin debris and artificial biofilm. The canals were filled with irrigation, and the models were assigned randomly to the following irrigation protocol. First, needle irrigation, which was the control group. Second, eddy activation, and third was laser activation irrigation. Isthmus images were taken before and after irrigation, and the amount of removed hydrogel were determined using image analysis software. Visualization of the isthmus during activation was achieved using a high-speed camera. For the results, all the irrigation protocol showed a significantly greater biofilm removal in short, wide isthmus than in narrow isthmus. Laser activation irrigation showed greater biofilm removal in short and wide isthmus than in long and wide isthmus. Laser activation irrigation and eddy activation resulted in a significantly greater biofilm removal than needle irrigation in every isthmus configuration. For the high-speed imaging, eddy activation produced a continuous and steady flow, while the flow produced by the laser activation irrigants were pulse with short and fast flow. Laser pulse produced a primary cavitation bubbles above the canal entrance. Appearance and growth of the bubbles of order of magnitude of 0.5 mm over the entire length of both canals and 0.25 mm in the isthmus was seen. These bubbles appeared rapidly and imploded soon after implosion of the primary bubble. This caused a vertical liquid movement in the canal and horizontal movement in the isthmus. In conclusion, with the limitations of the laboratory studies, it is possible to conclude that the isthmus morphology influences debridement efficacy of activated irrigation. Short, wide isthmus were the easiest to clean, while narrow isthmus were the most challenging to clean. Isthmus width seems to be a more critical anatomical parameter than isthmus length. Laser activation, irrigation, and eddy activation resulted in a greater hydrogel removal than needle irrigation. Eddy device produced eddies and stable cavitation in the isthmus, and the laser activation irrigation showed transient cavitation and pulsed horizontal flow.